These are ncert in-text questions from the lesson Chemical Kinetics. For the reaction R gives P, the concentration of reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of the reaction using units of time both in minutes and seconds. Average rate is equal to minus delta R by delta T. That is final concentration minus initial concentration R2 minus R1 divided by delta T. Now let us substitute the values. Minus 0.02 minus 0.03 by 25 minutes, that is minus 0.01 by 25, that is equal to 0.01 by 25. So when we simplify, we will get 4 into 10 raised to minus 4 molar minute raised to minus 1. Now we have to do this in seconds also. So let us convert minute into seconds. So first one, average rate in minutes. Then second case, we have to convert into seconds. So 0.01 divided by 25 into 60. So when we simplify, we will get 6.66 into 10 raised to minus 6 molar second raised to minus 1. In a reaction 2A gives products, the concentration of A decreases from 0.5 mol per liter to 0.4 mol per liter in 10 minutes. Calculate the rate during this interval. So rate is equal to, here the coefficient is 2, so we can write minus 1 by 2 delta A by delta T. So that is equal to minus 1 by 2 into change in concentration, that is final minus initial, 0.4 minus 0.5 divided by change in time, that is time interval is 10 minutes. So that is equal to minus 1 by 2 into minus 0.1 by 10. So that is equal to 0.1 by 20. So when we simplify, we will get 0.005 mole liter raised to minus 1 minute raised to minus 1. For a reaction A plus B gives products, the rate law is given by R is equal to K into concentration of A raised to 1 by 2 into B raised to 2. What is the order of reaction? So order is equal to sum of the powers of the concentration terms in the rate law expression. So concentration of A raised to 1 by 2. So 1 by 2 plus 2, that is equal to 2.5. The conversion of molecule X to Y follows second order kinetics. If concentration of X is increased to 3 times, how will it affect the rate of formation of Y? So what's the initial rate according to the question? It is a second order kinetics. That means rate is equal to K into concentration of X raised to 2. That is the initial rate. Now when x equal to 3x, that is x is increased to 3x, now the rate becomes R2 is equal to K into concentration of x becomes 3x, so 3x raised to 2. So K into 9 into concentration of x square, that is we can write 9K into concentration of x square. Now we can compare the initial rate and final rate. that is R2 by R1 is equal to 9kx square divided by kx square, that is R2 by R1 is equal to 9 or R2 is equal to 9 R1. Now the rate become 9 times of the initial rate. Reaction has rate constant 1.15 into 10 raised to minus 3 second inverse. How long will 5 gram of this reactant take to reduce to 3 gram? So this is a first order reaction. So first order reaction rate constant K is equal to 2.303 by T log initial concentration, that is R0, by final concentration, that is R. Now here we have to calculate the time. How long means we have to calculate the time. So T is equal to 2.303 by K. Rate constant is given as 1.15 into 10 raised to minus 3 second inverse log initial concentration is 5 gram and final concentration is 3 gram. So that is equal to 2.303 divided by 1.15 into 10 raised to minus 3 into log 5. Log 5 is 0.6990 minus log 3 is 0.4771. That is equal to 2.303 divided by 1.15 into 10 raised to minus 3 into, when we subtract this 0.6990 minus 0.4771, we will get 0.2219. So let us substitute that value here, 0.2219, that is equal to, when we simplify this, we will get 444 seconds. Time required to decompose SO2Cl2 to half of its initial amount is 60 minutes. So half-life is given. If the decomposition is a first order reaction, calculate the rate constant for the reaction. So for first order reaction, T half is equal to 0.693 by K. Half-life period is equal to 0.693 by K. So here half-life is given. So K is equal to 0.693 by T half, that is equal to 0.693 divided by 60 minutes. So when we simplify, we will get 1.155 into 10 raised to minus 2 minute raised to minus 1. What will be the effect of temperature on rate constant? According to Arrhenius equation, for a chemical reaction with a rise in temperature by 10 degrees Celsius, the rate constant nearly doubles. So we can write the Arrhenius equation as K is equal to A e raised to minus Ea by RT, where A is the pre-exponential factor, that's a frequency factor or Arrhenius factor, and Ea is the energy of activation, R is the universal gas constant, and T is the absolute temperature. So when we increase the temperature, the fraction of molecules which collide with energy equal to Ea or greater than Ea increases. Now, the rate constant of a chemical reaction doubles for an increase of 10 Kelvin in absolute temperature from 298 Kelvin. Calculate Ea. So let us write the equation. Log K2 by K1 is equal to log K2 by K1 is equal to Ea by 2.303 R T2 minus T1 by T1 T2. So here an increase of 10 Kelvin from 298. So we can take T1 as 298 and T2 as 308. Then universal gas constant is 8.314. So log K2 by K1 is equal to EA by 2.303 R, that is EA by 2.303 into 8.314, T2 minus T1, 308 minus 298 by T1 T2, that is 298 into 308. Here it's given log K2 by K1 means it is written it doubles. So K2 is 2 times of K1. So we can write log 2 K1 by K1 is equal to EA by 2.303 into 8.314 into 10 divided by 298 into 308. Now we will get log 2 K1 by K1 means log 2, that is equal to 0.3010. Now we can write EA is equal to 0.3010 into 2.303 into 8.314 into 298 into 308 by 10. So when we simplify this, we will get 52898 joule per mole. So we can convert into kilojoule, that is 52.898. We can write it as 9 kilojoule per mole. Kilojoule per mole. The activation energy for the reaction to HI gives H2 plus I2 is 209.5 kilojoule per mole at 581 Kelvin. Calculate the fraction of molecules of reactants having energy equal to or greater than activation energy. So fraction of molecule which is possessing energy equal to or greater than activation energy, we can write it as E raised to minus EA by RT. This is the fraction of molecules. Fraction of molecules which is possessing energy equal to EA or greater than EA. So let us write it as X. So X equal to E raised to minus EA by RT. Now take logarithm on both sides. So ln x equal to ln e raised to minus EA by RT. That is equal to minus EA by RT ln E. Ln E is equal to 1. So we will get minus EA by RT. Now ln x we can write it as 2.303 log x, that is equal to minus EA by RT. So log x equal to minus EA by 2.303 RT. Now let us substitute the values. Minus 209.5, we can write it as 209.5 in joule. I will convert into joule because R value we are going to substitute in joule per Kelvin per mole. So R is 8.314 and temperature is 581. So when we simplify, we will get minus 18.83. Then x equal to anti-log of minus 18.83. So when we simplify minus 18.83, when we convert, we will get bar 19.17. So that is equal to 1.47 into 10 raised to minus 19. that is the fraction of molecules is equal to 1.49 into 10 raised to minus 19.